Did you know that, according to Einstein's theory of relativity, time is not absolute, but relative, and can be affected by speed and gravity? This means that, in theory, we are already traveling in time, only to the future, and at different speeds depending on where we are and how fast we move. Intriguing, isn't it? Stick with me, that's just the beginning. Hello curious minds and welcome to my channel. Here, we explore the most intriguing facts, the most bizarre stories, and the most surprising curiosities in the world. I'm Jack, and together, we'll dive into a universe of knowledge and question, is this real or fake? Today's topic is one of the greatest dreams and paradoxes of humanity: time travel. Is it possible to go back to the past or visit the future? And if so, what would be the consequences? Scientists have recently announced a discovery that could change everything we know about time. Get ready to have your minds blown. Let's start with the basics. What does science, particularly physics, say about time travel? Albert Einstein's theory of relativity, published in two parts, in 1905, Special Relativity, and 1915, General Relativity, revolutionized our understanding of space and time. One of the main conclusions of the theory is that time is not absolute, as previously thought, but relative, that is, it can pass differently for observers in different states of motion or in different gravitational fields. This means that, in theory, time travel to the future is already a reality, albeit on a very small scale. For example, astronauts aboard the International Space Station, who move at high speed relative to Earth, age slightly slower than we do down here. This effect, called time dilation, has already been experimentally proven with high-precision atomic clocks. Another implication of relativity is that gravity also affects time. The stronger the gravitational field, the slower time passes. This means that time passes a little slower at sea level than on top of a mountain, where gravity is slightly weaker. This difference, although minuscule, has also been measured experimentally. But what about time travel to the past? General relativity also opens up this possibility, in theory, through exotic mathematical solutions, such as wormholes and cosmic strings. But are these solutions physically feasible, or just mathematical curiosities? Let's explore some of these exotic solutions. Wormholes, also known as Einstein-Rosen bridges, are hypothetical shortcuts through space-time, connecting two distant points in the universe, or even two different universes. In theory, a wormhole could be used to travel in time, both to the past and to the future. However, there are several problems. First, the existence of wormholes has not yet been proven. Second, even if they exist, they would probably be extremely small, unstable, and require a colossal amount of exotic energy, with negative energy density, to keep them open and traversable. This exotic energy, which would have anti-gravitational properties, is still purely theoretical. Another theoretical possibility is cosmic strings. These strings, if they exist, would be remnants of the Big Bang, incredibly thin and dense, with enormous gravitational tension. According to some physicists, if two cosmic strings passed each other at high speed, or if a cosmic string passed near a black hole, this could warp spacetime in such a way that it would create closed time-like curves, allowing, in theory, time travel to the past. But again, the existence of cosmic strings has not yet been proven, and the engineering required to manipulate them would be far beyond any imaginable technology. In addition to these solutions, there is also the paradox of the Tipler cylinder, proposed by physicist Frank Tipler. This cylinder, infinitely long, extremely dense, and rotating at high speed, could, in theory, distort spacetime around it in order to create closed time-like curves. However, the construction of a Tipler cylinder is considered physically impossible, as it would require matter with infinite density. Even if time travel to the past is theoretically possible, it raises a series of logical paradoxes that challenge our understanding of causality and reality. The most famous of these is the grandfather paradox. Imagine you travel to the past and prevent your grandparents from meeting. If they never meet, you will never be born. But if you were never born, how could you have traveled to the past in the first place? This paradox suggests that time travel to the past is impossible, as it would create logical inconsistencies in the timeline. Another paradox is the predestination paradox, or ontological paradox. Imagine you receive a book from the future, containing information about events that have not yet happened. You use this information to predict the future and make decisions. But where did the information in the book come from? It was not created in the present, but in the future, which does not yet exist. This paradox suggests that information can emerge from nothing, violating the principle of causality. To try to resolve these paradoxes, physicists have proposed various hypotheses. One of them is the self-consistency hypothesis, or Novikov's self-consistency principle. According to this hypothesis, time travel to the past is possible, but only in a consistent way. That is, you cannot change the past, because any attempt to do so is already part of history. If you tried to kill your grandfather, something will prevent you, or you will find out that he was not your biological grandfather, or anything else that keeps the timeline consistent. Another hypothesis is the many worlds interpretation, or parallel universes, of quantum mechanics. According to this interpretation, every time a decision is made, or a quantum event occurs, the universe splits into multiple universes, one for each possible outcome. So if you travel to the past and kill your grandfather, you simply create a parallel universe where you were never born. But the original universe, where you came from, remains unchanged. This interpretation eliminates the paradoxes of time travel, but at the cost of postulating the existence of an infinite number of universes. In addition to theoretical issues and paradoxes, there are also practical and technological challenges to time travel. Even if it were possible to build a time machine, the amount of energy required would be astronomical, far beyond anything we can generate today. Also, the precision needed to travel to a specific point in the past or future would be extreme. A small miscalculation could result in a deviation of centuries or millennia. And of course, there are the unknown risks of interacting with the past or the future, which could have unpredictable consequences. And what about recent claims by scientists about discoveries related to time travel? It is important to analyze this news with caution and skepticism. Often, what is reported as a discovery about time travel is actually a theoretical advance in particle physics or cosmology, which has potential implications for time travel, but is still far from becoming a practical reality. For example, the recent detection of gravitational waves, ripples in space-time predicted by Einstein, is an incredible scientific achievement, but it does not mean that we can build a time machine. Similarly, the creation of black holes in the laboratory, or the manipulation of particles at speeds close to the speed of light, are important experiments that help us better understand the nature of space and time, but they are not the same as traveling in time. Despite the challenges and uncertainties, time travel remains a fascinating topic for science and science fiction. The idea of being able to revisit the past, correct mistakes, witness historical events, or meet the future is irresistible to the human imagination. But is time travel really something we should desire? What would be the ethical implications of changing the past, even with good intentions? And if we could predict the future with certainty, would that make us wiser, or just more anxious and paralyzed? Time travel raises profound questions about the nature of time, causality, free will, and destiny. In addition, the search for time travel, even if it never materializes, can lead to important scientific and technological advances in other areas. The study of relativity, quantum physics, cosmology, and gravitation, driven in part by curiosity about time travel, has contributed to the development of technologies such as GPS, lasers, nuclear energy, and space exploration. Therefore, even if time travel remains in the realm of science fiction, research and speculation on the subject can have real benefits for humanity. It is also worth distinguishing time travel, as we generally understand it in science fiction, from the possibility of obtaining information from the past or the future by other means. For example, astronomy, in a sense, is already a way of looking into the past, since the light from distant stars and galaxies takes millions or billions of years to reach us. By observing these objects, we are seeing what they were like a long time ago. And in theory, if we could move faster than light, which, according to relativity, is impossible, we could catch up with the light that left Earth in the past and see historical events happening. But that would not be the same as physically traveling to the past. And now, my favorite part, your opinion. After exploring the theories of physics, the logical paradoxes, the technological challenges, and the philosophical implications, what do you think? Is time travel possible, at least in theory? And if so, would you like to travel to the past or to the future, and why? What historical events would you like to witness? Or what changes would you like to make, if you could? And what are the risks and responsibilities that would come with that power? Share your theories, opinions, and reflections in the comments. Remember, here we encourage curiosity, speculation, and the exchange of ideas, but always with respect, politeness, and an open mind for debate. After all, knowledge is built that way, by questioning, investigating, and sharing. If you enjoyed this video, subscribe to the channel, turn on notifications to receive updates, give it a thumbs up, which helps a lot, and share it with your curious friends who are also fascinated by the mysteries of the universe. In the next episode, we'll unravel another intriguing mystery that will challenge your beliefs and expand your horizons. Until next time, and remember, the world, and who knows, time, is full of curiosities to be explored.